Hello again, this is Doug Lowen, UNC Public Policy, in what is becoming a very long tutorial on bivariate statistical testing. We have one more t-test to discuss, and then we should be able to squeeze in the proportion test here and the chi-squared test here. So the second t-test tests whether the test scores of kids in states is related to child poverty. So the research hypothesis here would be, again, that there's an inverse relationship, that as child poverty goes up, test scores should go down. Okay, so first we just get the summary statistics, then we t-test the mean difference the same way we did up here. So let's just highlight that, click do, go to our output. Okay, so we see that in states with low child poverty rates, so child poverty equals 0, test scores are higher than in states where child poverty rates are high. Remember, this is coded high if 1 and low if 0. And read is a continuous variable, so we're getting the mean of that continuous variable in each level of this binary variable. Okay, so now we want to test the mean difference between these two groups. The mean difference is actually larger than what we saw before. We had a mean difference of about 4.99. In this case, the effect is stronger at 6.83. So this suggests that our alternative explanation is at least related to our outcome variable, reading. The question is it also related to our independent variable, which is pupil-teacher ratio? The t statistic is 4.15, which is large enough to reject the null hypothesis at alpha 0.05, two-tailed, and of course also at one-tailed. So there's pretty good evidence here that we can reject the null hypothesis of no difference. This is a pretty large effect, even though we have only 51 states. So now let's see if our alternative explanation about child poverty is related to our pupil-teacher ratio. We could, of course, do this with the continuous variables, but I want to demonstrate the proportion test, so I'm going to do it first that way. So first I'm just going to summarize the pupil-teacher ratio. This is going to be about 0.5 because we've done a median split here. And then I'm going to summarize pupil-teacher ratio if child poverty is low and then if child poverty is high. And if these means or proportions here are different, then we might have some reason to do a statistical test. And we'll do that here with, instead of the t-test, the proportion test. So we have, again, the format is the same here. Just like the t-test, in the proportion test, we have the dependent variable here and the independent variable here. Okay, so let's highlight all that and take a look. Click do, go to our output. Okay, so on average, just as I said, the mean of this proportion is about 0.5 or 0.47. The mean, the percentage of states that have high pupil-teacher ratios in the group of states that has low child poverty is 38%. The percent of states that has high pupil-teacher ratios and high poverty, child poverty equals 1, is 56%. So we can see that there's a positive relationship between these two variables. Now the question is whether the statistical test would be able to tell us that these two means or these two proportions are actually different in the population. So the mean difference is about 0.17. The z statistic in this case is negative 1.25, which is not sufficient evidence to reject the null hypothesis in a two-tailed test at alpha 0.05. It's marginally significant on a one-tailed test, but p-value is still above 0.1, and the conventional level is 0.05. So we can see some tentative evidence that there's a positive relationship here, although the difference is not large enough to reject the null hypothesis. So we're going to get to the chi-squared test in the next tutorial, and then show you how to control for a variable in a crude way.